Welcome to Astra the Exo Marketing Podcast. I'm Jessica Curse.
And I'm Xylo the droid.
Today we're jumping into something pretty futuristic, but also getting very real. Space-based solar power. SBSP for short.
That's right, the idea of, collecting solar energy way up in orbit and then beaming it down here.
So we're going to explore how this is moving from science fiction to actual engineering projects, and crucially for us, what kinds of marketing opportunities pop up when you mix space tech, clean energy, and, well, global impact. The basic concept, space-based solar power. Can you break that down for us? What are we actually talking about?
Sure. So basically you put enormous solar panels, huge arrays, into space, probably geostationary orbit.
Geostationary meaning it stays over the same spot on Earth.
Exactly. And the big advantage there, it's bathing in sunlight almost all the time, like 99% of the time. So these arrays capture that solar energy, convert it on board, and then transmit it wirelessly back to Earth.
Wirelessly? How?
Usually using either microwaves or potentially lasers. Then on the ground, you have receiving stations, rectennas they're often called, that capture that energy and turn it back into electricity for the grid.
Okay, so it's ambitious, definitely. Sounds like it could reshape a lot of things.
Oh, absolutely. Both energy and space.
It makes sense immediately why you'd want to do this in space. Solar power on Earth is great, but obviously you've got nighttime, clouds.
Weather, pollution, seasons.
Yeah.
And you need a lot of land, which can be a problem.
Right. So how much better is it really in space?
Well, that near constant sunlight in GEO orbit is the big one. You get something like over double the energy per square meter compared to down here, at least. Plus, you avoid all those terrestrial issues, no clouds, no atmospheres scattering the light as much, no competing for land or water use. It's just a much more efficient place to collect solar energy.
You mentioned the transmission microwaves and lasers. Can you tell us a bit more about those? How do they differ?
Yeah, so microwaves are kind of the leading contender right now. They're looking at frequencies like 2.45 or maybe 5.8 gigahertz.
Okay.
The good thing is those frequencies can pass through the atmosphere pretty well, even through clouds, relatively efficiently and safely at the projected power levels. The ground stations, the rectennas, are basically large fields of antennas designed to capture that microwave energy. Specifically, infrared lasers are the other option. They offer a much tighter, more focused beam, so you could potentially direct power more precisely maybe to smaller receivers.
But there's a catch.
Yeah, the downside is they need a clear path. Clouds, heavy rain, that sort of thing could block or scatter the beam. So there are trade-offs. And, of course, a lot of work is going into making both methods safer and more efficient over those huge distances.
Who are the big players actually pushing this forward? Any major projects we should know about?
Oh, yeah, there's definitely serious work happening globally. One really notable one is Caltech's Space Solar Power Project, SSPP.
Caltech, right. I heard about their launch.
You probably heard about MAPLE. That was their orbital experiment launched in 2023. It was a huge milestone.
What did it do?
Well, it was the first time anyone demonstrated wireless power transmission in space from one part of the spacecraft to another. And crucially, they actually managed to detect a tiny amount of that beamed energy back on Earth. A world first.
That's incredible, sending power from orbit back down.
Even a tiny bit, yeah, to prove the concept. And their project is also focused on things like lightweight, foldable arrays and how you'd actually assemble these massive structures autonomously in orbit. That's key for making it practical long term.
Okay, so Caltech in the U.S. Who else is making big moves?
Japan. JAXA, their space agency, has been a leader for a long time, especially on the ground transmission tech.
What have they done?
Way back in 2015, they beamed, I think it was 1.8 kilowatts, enough to boil a kettle over 55 meters on the ground. Pretty impressive demo.
And their space plans?
They have a really ambitious goal for 2030, a 1 gigawatt operational system. That's enough to power like 300,000 homes.
A gigawatt by 2030, that's soon.
It is ambitious. They're planning orbital prototypes in the next, say, 5 years or so to scale things up.
Okay, U.S. and Japan are in. What about Europe?
Europe's definitely getting serious, too. The European Space Agency, ESA, launched their Solaris initiative back in 2022.
Solaris, what's their angle?
They're taking a very thorough look partnering with big aerospace companies like Airbus and Thales Alenia, plus universities. They're digging into the economics, the politics, how it fits into the EU's energy strategy.
So feasibility studies mainly.
A lot of that, yes, but also planning potential tech demonstrators. ESA sees it potentially supporting the main grid, but also, interestingly, for things like disaster relief beaming power quickly where it's needed.
That disaster relief angle keeps coming up. Makes sense. And China, they're usually involved in big space projects.
Oh, absolutely. China has very significant long-term plans. They've built a test facility in Chongping specifically for high-altitude power beaming tests.
A dedicated facility.
Yep. And their roadmap is pretty clear. They want a full-scale 1-megawatt satellite demo up by 2030. And then looking further out, multi-gigawatt systems may be operational by 2045. They're thinking big.
Any unique aspects to China's approach?
Well, they've explicitly talked about linking SBSP to their Belt and Road Initiative, kind of like orbital diplomacy, offering clean energy from space to developing nations. Raises some interesting geopolitical questions for sure.
Wow. Okay, so we've got these huge projects aiming for the sky. But let's bring it back down to Earth. How would this tech actually, change things for people on the ground?
The impacts could be really profound. Take disaster response, like we mentioned. Imagine a hurricane or earthquake takes out the power grid. With SBSP, you could potentially beam power directly to hospitals, emergency shelters, command centers for relief teams. No need to wait for roads to clear for fuel trucks or for the grid to be rebuilt. It could be almost instant power where it's needed most.
That alone would be revolutionary in those situations. What about more everyday uses?
Well, think about cities. SBSP could feed into urban microgrids, making them more resilient. Maybe someday skyscrapers could get a direct feed from space, reducing load on the terrestrial grid and freeing up land.
Interesting. Powering buildings directly.
Or think about remote places, Arctic research stations, isolated villages in, say, Africa or the Himalayas, places where building traditional grid lines is incredibly expensive or just impractical.
Right. The infrastructure cost is huge.
SBSP could bypass all that, provide reliable, clean power. That enables so much education, healthcare access, new business opportunities. It could be transformative for energy access globally.
And it's not just Earth, is it? You mentioned space applications, too.
Absolutely critical for future space exploration.
Yeah.
A moon base, for example. The lunar night lasts for 14 Earth days. It gets freezing cold and dark.
Right. Providing continuous power there is a major challenge.
SBSP could solve that. Beam power down during the long night. Same for Mars. Mars gets less sunlight than Earth. The atmosphere is tricky. SBSP could be a reliable power source for colonies.
And for infrastructure in orbit.
Yeah, powering satellites without needing huge solar panels on each one, maybe space tugs moving things around, future space stations or habitats, less reliance on carrying heavy fuel or batteries. It could really enable a lot more activity off-planet.
Okay, the potential is clearly massive, but let's be realistic. What are the big hurdles? Cost has to be one, right?
Oh, definitely. Current estimates for, say, a 1-gigawatt system are steep. Maybe in the range of $15 to $20 billion.
Wow. How does that compare?
It's roughly comparable to maybe almost double the cost of a big nuclear power plant. So, yeah, significant investment needed.
But costs in space are coming down.
They are. That's the hope. Reusable launchers, like SpaceX's Starship, could drastically cut the cost of lifting all that hardware into orbit. And advances in lighter, more efficient materials for the arrays themselves will help too. So that number should come down over time.
Okay, cost is one. What else? Safety must be a huge concern. Beaming energy from space.
Paramount. Absolutely. You need guarantees that the beams are safe, that they won't harm airplanes flying through or wildlife or people on the ground. Fail-safes are critical.
And controlling the beam accurately.
Exactly. Precise targeting and immediate shutdown capabilities if anything goes wrong. Regulation will be key here, setting strict safety standards.
Which brings us to policy. Who owns the orbital slots? How do you prevent someone weaponizing this?
Yeah, those are big questions that need international answers. We need agreements on orbital lanes, frequency allocation, rules to prevent militarization, and frameworks to ensure this doesn't become a monopoly controlled by just one country or company. Fair access is important.
And efficiency. Are we losing a lot of power in transmission?
There are losses, yeah. Currently, the end-to-end efficiency from sunlight in space to usable electricity on the ground might be somewhere in the maybe 30–40% range, meaning 60–70% loss.
That sounds like a lot.
It is, but it's improving. Research is ongoing to boost the efficiency of the solar cells, the conversion to microwaves or lasers, the atmospheric transmission, and the ground reception. Every percentage point helps the economics.
So cost, safety, policy, efficiency, quite a few challenges. But given the progress, what's the general feeling about a timeline? When might we actually see this contributing meaningfully?
The consensus seems to be shifting. Many analysts think we could see the first, maybe smaller scale, demonstrators say, in the 100 megawatt range up and running by the end of this decade, so around 2030. Then commercial scale and getting to those gigawatt level systems we talked about, that's probably more likely in the 2040s.
Which lines up pretty well with net zero goals.
Exactly. It can become a really important tool in the climate change fight, providing clean baseload power, potentially by mid-century when we really need it.
Okay, this is Astra, the EXO marketing podcast, so let's pivot to the marketing side. With something this huge and, frankly, kind of sci-fi sounding, how do you market it? What strategies should we be watching for?
That's a great question. I think one key shift we'll see, or should see, is moving the story beyond just the cool tech.
Beyond the rockets and lasers.
Yeah, well, that's exciting. The really compelling marketing angle is likely the social impact. How does this help fight climate change? How does it bring power to underserved communities? How does it make us more resilient, focusing on those tangible human benefits?
Making it relatable, basically, connecting space innovation to global sustainability.
Precisely. Frame it not just as an engineering marvel, but as a solution to real-world problems. That helps build broad support.
What else? Given the safety concerns and the scale, trust must be huge.
Absolutely crucial. So I expect we'll see a big emphasis on transparency, maybe open dashboards showing project status, live stream tests, even the small ones, detailed mission logs, anything that shows progress and, importantly, safety openly.
Building trust through visibility. How about the core message itself?
I think we'll see a lot of what you might call space-Earth dual messaging.
Dual messaging.
Yeah, telling two stories side by side. Story one, the incredible innovation happening up there, the giant arrays unfolding, the precision beaming, the autonomous robots assembling things, capturing the wonder.
Okay.
Story two, the direct impact down here, showing a clinic in a remote area, getting power, illustrating reduced emissions, maybe visualizing a city partly powered from orbit, connecting the space achievement to tangible Earth benefits.
You get both the wow factor and the so what factor.
Exactly. It addresses both the aspirational and the practical.
And collaborations. Do you see partnerships playing a role in the marketing?
I think that'll be huge. Co-branding could be very powerful. Imagine an SBSP initiative partnering with a major trusted energy company or with a big tech firm that needs massive amounts of clean energy for its data centers.
Or even humanitarian groups.
Yeah, partnering with disaster relief organizations to demonstrate that capability. These kinds of tie-ins lend credibility, expand the audience, and show real-world application very clearly.
So boiling it down for our listeners, many of whom are involved in marketing, space, tech, or related fields, what's the key takeaway here from SBSP?
I'd say focus on the story behind the technology. Yes, the engineering is amazing, but people connect with human impact. How does this make life better? How does it contribute to a future we want?
Tell the story of impact, not just specs.
Exactly. Connected to those big goals. Climate action, energy equity, resilience. Find the human angle.
Any other advice for the EXO marketer looking at projects like this?
Try to build community ambassadors. Empower different groups, scientists, environmentalists, maybe even community leaders in areas that could benefit. And finally, speak the language of hope and, crucially, action. Frame it not just as cool tech, but as a positive force for change. You're marketing the possibility of ending energy poverty, of, beaming light into darkness, quite literally.
That's a powerful way to put it. So wrapping up this deep dive, it really feels like space-based solar power isn't just out there anymore. It's a serious contender with huge potential to change our energy landscape.
It really is. And from a marketing perspective, it's a masterclass in how you take something incredibly complex and connect it to fundamental human needs and aspirations.
Definitely challenges ahead, but the momentum seems real. And the marketing lessons about transparency, impact storytelling, and building trust are applicable across so many innovative fields.
Couldn't agree more. It really highlights that link between pioneering technology and communicating its value effectively.
Well, this has been fascinating. If you found this journey into space-based solar power and its marketing dimensions enlightening, please do like and subscribe to Astra, the EXO Marketing Podcast. We've got lots more coming up.
Always exploring the frontiers.
And our slogan for today, reach for the stars, power the world. Stay tuned for our next deep dive where we'll be getting into.
That's going to be a good one.
I have to tune in to find out. Thanks for joining us.